Welcome to Unit 4, Resource Issues. This is Introduction to Environmental Science, South Florida State College. Lecture number 12, Freshwater Resources. Well, yeah, Florida-centric. That's what we're looking at. Looking at all these freshwater resources we have, groundwater, surface water, all those things. Protecting those aquatic ecosystems as well. So, some fill-in-the-blank questions. First of all, where does our drinking water come from? We'll fill in that blank just a moment. Give you a second to go research it, Google it. Where does our irrigation water come from? That one may be a little harder to Google, although I would imagine the word will come up. How large is this groundwater source? How far does it extend? Close parentheses there, by the way, is optional. What legislation, signed into law in 2016, impacts our water supply? Now that one you definitely would have to Google, wouldn't you? Alright. So the first question, where does our drinking water come from? Well, the correct answer is the Floridan Aquifer. That's where our drinking water comes from for most of central Florida. It's unusual for a large area like ours to depend upon a groundwater source, but that's where ours comes from. Irrigation water, for the most part, the largest source of irrigation water in all of South Florida north of Lake Okeechobee is Lake Istokpoga, consumptive use water. So in Highlands County, certainly it's Lake Istokpoga, the surface water source. So, third question, how large is this groundwater source? Bigger than a bread box, for sure. It extends all the way up into Georgia and South Carolina. I'll show you a map of it in a bit, but it's quite extensive. Ranges very, very long way away from where we are in Central Florida. And that legislation is Senate Bill 522. We have a discussion forum that's open for this unit. Please see that, and you'll get to discuss it and look at what exactly it means and why it might be good, and some things that might not be so good about it. So, what we're talking about today, water shortages. Where is our water used and where does it come from? Droughts and water shortages, impacts of the water supply system itself, and impacts of excessive groundwater withdrawals. We'll see those. Impacts of dams and reservoirs. Lots of impacts in this lecture. Creating a sustainable water supply system. Flooding. Problems and solutions. Despite widespread water shortages, flooding is still a serious problem in many parts of the world. Causes of flooding. Controlling flooding. Let's look at water shortages. Water shortages are a function of uneven distribution, excessive demand, and inefficient use. So let's see this is a nice, graphical representation of the Floridan Aquifer system. Where is the water used? Well, mostly it's used for agriculture and mining, right there in the central part of the state, that is the Florida Peninsula, kind of in relief there. It's also used for drinking water for people along the coast. That happens to be pointing right at Tampa Bay, if you can't quite see where that is. But that would be true for almost anywhere up and down the west coast of Florida. Where does it come from? Well, it comes from, for us, here at South Florida State College, there we are, right there in the middle of the Highlands Ridge. It comes from the Floridan Aquifer system. What is the extent of the Floridan Aquifer system? Well, oops, you saw that slide. Let's go forward rather than backward. Yeah, that's good. This map from 1980 actually shows the extent of the approximate upper limit of the Floridan Aquifer. It's all the way up here, Georgia, South Carolina, even a little piece of Alabama over here. Looking at this map, the Floridan Aquifer system, FAS for short, extends into Georgia and into South Carolina. It's very interesting. You see that the darker blue colors are where the largest water use was in 1980. I bring this up because it's not that way anymore. Notice that the coasts are not as well represented. You also notice that this part of Florida does not use the Floridan Aquifer system for its water supply. It uses a surface water system. We'll talk about that later too. Anyway, Polk County phosphate mines dominated water use in Central Florida in 1980. So what is the Floridan Aquifer system? FAS for short. Let's look at a diagram of it. Once again, South Florida State College is approximately right there. This is a schematic. This isn't the actual thing, but imagine that we're right there, kind of in the middle, on the edge of a lake and kind of on the edge of a stream, all that sort of stuff. So there's this limestone layer down in here that makes up the Floridan aquifer system, and it acts as a sponge. Fresh water is all of this part of it in here. You can see where all of those, the freshwater system extends all along there. 150 feet down is the superficial aquifer. 500 feet down is the intermediate aquifer. That's the depth of those wells approximately. And you get to deep, where we get our drinking water from. 1,500 feet is where the actual Floridan aquifer is located. Keep going down further, and you end up in brine. Saltwater brine is, if you go below 1,500 feet, it's really not going to be good water. This is obviously a map outline of Highlands County, where we're located. How does our clumped population affect water supply? So where do the people live in Highlands County? Pretty much up and down this part of the ridge. You can kind of see it. The cities are up and down inside there. Well, how about ag? Where is the agriculture in Highlands County clumped? Well, the surface, the population uses that Floridan aquifer system, but agriculture tends to use these superficial sources, particularly out of Istokpoga. You notice there's a stream running down here called Fish Eating Creek. There's another creek, if you will, running down there called Arbuckle Creek. These superficial sources are very important in terms of agriculture and their ability to get water. And it also is clumped as well. Looking at water shortages, a function of a variety of things. An uneven distribution of water, excessive demand. So you have the distribution is not where the people need to use it. Demand is too high. And use can be very inefficient. These are fairly simplistic ways of looking at water shortages. So where is the water used actually? And where does it come from? So here in Highlands County, Istokpoga, number one source of permitted consumptive use water in the Kissimmee Valley. If you look at the actual source, just walk our way through this. S68, the surface, the outlet from Istokpoga is known as structure 68 or S68. 2005, the actual use out of Istokpoga was 110 million gallons per day. That's an awful lot of water. That is by far the bulk of the water used, and certainly in this county. Notice that number is not supposed to change between 2005 and 2025, that 20-year period. The groundwater, which is the public supply, in 2005 stood about 12 million gallons a day. That's how much we pump out of the Floridan aquifer every day on average. Projected to increase by about 4 million gallons a day, which is a lot of water, given all the conservation that we're supposed to be putting in place. You'll notice that agriculture, use of groundwater. Now all the surface water here is used for agriculture. The groundwater, agriculture's use of groundwater, is actually going to decline. Part of that is a reduction in the amount of ag that is citrus, essentially. Maybe that projection may be even lower than that now, given some other things that have changed. We'll talk about that in later chapters. But also it's an increase in the efficiency. That's not a very large reduction. And then recreation, groundwater uses for that, are actually projected to increase by about 1.4 million gallons a day. That's a fairly large amount. When you look at globally, agriculture and industry, just like in this county, agriculture certainly is the major user of water. So this is annual withdrawals of water by various countries. This is India. India is the number one. You see most all of their water is used for ag. I wonder if I animated this. Nope, let me go back. Okay. China is number two largest nations as far as population on Earth. Most of their use is for agriculture. U.S., we are the third largest, and we're number 3 in terms of the use, but most of our use is actually industrial. It's not agriculture. Go to Indonesia, the 4th largest, most populous country in the world, or it is today, and most of theirs, once again, is agriculture. And you can go down this list. It drops off fairly substantially after Indonesia in terms of the use. You can see that Russia, this line here, is mostly using theirs also for industrial purposes. Germany is using almost all of theirs for industrial purposes. And there's a mixture as you go on down with the smaller countries represented. So what are the major uses of water in the United States? This might surprise somebody. Public supply drinking water is actually the third most common use of water. Irrigation is number 2, irrigation for agriculture. You had livestock, aquaculture, all those sorts of things. But the number 1 use of water is this thing called thermoelectric uses. Basically, it's used for industry, for cooling water, for power plants. 142 million gallons per day of water is used to actually cool power plants. I think it's probably more than that. 142 million gallons a day is a lot of water. That is where the majority of our water use is in this country. This is a graphic showing the water use in the United States. You can follow that link there to the USGS's water use graphic. If you add this surface water source and this groundwater source together, you come up with this total supply, total use every day. 87% of the water used in the United States comes from other supplies. 13% is used for public supply. Looking at surface water, a lot more surface water. 89%, or I'm sorry, 240 million gallons a day is withdrawn from surface water for, well, that's the industry. That's the thermoelectric cooling. That's all those sorts of things. As far as groundwater is concerned, most of that groundwater use, that 65 million gallons per day that is withdrawn as groundwater, is primarily used for agriculture, for I would say for irrigation. Public supply makes up a smaller portion of the drinking water that we actually use out of each of those. Still have droughts and water shortages. Droughts, natural causes of water shortages. And of course, we make it worse. This is a recommended book. It's old. It's somewhat dated. Old meaning it's from the 1990s. Called Cadillac Desert, the American West and its Disappearing Water. One thing about the American West, anything that's really west of the Rocky Mountains, and certainly even in that part of the United States, is a very arid region. And we have been able to make the desert bloom by, well, manipulating how the water flows. Los Angeles, Phoenix, Las Vegas would not exist without a thing called the Bureau of Reclamation. These are the folks who built all those dams out there. California is enduring an extended drought. They've been going through this drought, and when you listen to this you may think, well, it's not going through a drought now. Well, they'll go through a drought again, trust me. The images of workers in Los Angeles right here removing sod. There's a rebate program that encouraged water conservation. You can see those guys rolling up that sod. Gave the public a $10,000 per lot incentive. I think they ran out of money, but that was to reduce, because irrigation, residential irrigation, is such a huge user of water in almost every situation. Droughts reduce water supplies, create social, economic, environmental problems. Let's look at Lake Fungibain. That's probably the wrong pronunciation, but that's as close. Mali I can get. Mali, yeah, I'm good with Mali, but I don't know. I can't pronounce the name of that lake. Mali, its population of 13 million, is in basically between the Sahara and the Sahel. It stretches between those. Now, here's a pop quiz. No points for this because this was on the last unit. So this is the birthplace of which grain crop? Real quickly, if I buzz in real fast. Sorghum, that's right. You would have gotten it right. 3.8% of the land of Mali is actually arable. In other words, you can actually farm it. The rest of it is pretty much desert. And the country is being edged towards being completely desert. Desertification. That's a word that rolls off your tongue. 1974, this lake, whose name I can't pronounce, Lake Fungibain, covered 230 square miles. Pretty good sized lake. By 2000, there was no lake there anymore. It was all dry. Now, rainfall has increased since 2000, but so has water use, and the lake has really struggled to refill. So images of Lake Fungibine. Top image is a composite from the 1970s. This is a nice full lake. Kind of an interesting looking lake. I'm not sure why. Maybe it's a reservoir, but anyway, it's got that flat thing going on there. And then the lower image is from the mid-2000s, a composite image. Most of that is not water. Most of that is dry rock. So, impacts of the water supply system itself. Water withdrawn from groundwater, which is how we get our water here. Surface water sources. Little is actually returned directly to that source. So when we pull it out of the ground, pump it out of the ground, how does it get back into the ground? Well, that's a hard question. Sometimes it does it through, sometimes it is. Fertilizer, when we add fertilizer to our surface water, that becomes a real problem. When it's applied to porous soils, like sandy soils we have here in this part of Florida, it ends up in the shallow groundwater, which rolls into lakes. Stormwater runoff, you have the same sort of an issue that runs directly into lakes. So water quality, let's look at two different measures of water quality. One of them is total nitrogen. This is a view of total nitrogen for 3 lakes. Lake Denton, which is a deep, clear lake, pretty high in total nitrogen though. Lake Persimmon, which is not quite so clear. And Lake Tulane. What's Lake Tulane's claim to fame? Well, Lake Tulane is supposedly the oldest lake in North America, based upon some studies that were done in the 1980s. It's more than 60,000 years old. Pretty old lake. So that's total nitrogen. You can see that Lake Tulane has pretty low total nitrogen numbers, and that's a healthy lake. Lake Denton and Lake Persimmon are not, they have high nitrogen numbers. Looking at transparency, though, that tells a little different story. Lake Denton has a very, very good transparency. 20 feet is very good. Lake Tulane, 15 to 20 feet, that's doing really well. Lake Persimmon is way down here. Lake Persimmon has very, very poor transparency. What's the difference between, well, particularly Lake Denton and Lake Persimmon, since they both have the same amount of nitrogen? Well, it's actually the amount of phosphorus present in Lake Persimmon. There's naturally high levels of phosphorus which allow algae to grow in Lake Persimmon, and they can't grow in Lake Denton or in Lake Tulane because the phosphorus is low in both those lakes. Water that is returned to its source is often laden with pollutants. That was kind of the point of that slide. Stormwater runoff. Lake Verona is a lake in downtown Avon Park that receives tremendous amounts of stormwater runoff directly from the watershed that surrounds it. High in oil, heavy metals, animal waste, nutrients, anything that's on your car can fall off your car and end up in that stormwater runoff. Sometimes just trash. It's implicated in much of the water quality problems that we see around the world, and we see here locally too. And then there's this idea of hydraulic fracturing. You may know it by a different name called fracking. Increasingly, it's the method used for extracting fossil fuel from recalcitrant geological structures, recalcitrant meaning hard to get to. Mostly this is used in the United States today. So let's look at fracking and see how it actually works. This is a diagram, 5 steps, and we'll go through each of these steps. You have acquisition of water, chemical mixing, part of we'll talk about what that is. You inject that down an injection well. That actually causes, under pressure, causes the fracturing. Then you have flowback and produced water, which produces wastewater. And then you have to do something with that wastewater, treatment and disposal of that wastewater. 5 steps, 5 easy steps. Number 1, large volumes of water delivered to or extracted at the site. Tremendous amounts of water are needed for this. Second of all, you have to make basically a chemical slurry, although a light chemical slurry, a thing called a propellant, which is a substance used to keep the cracks open once the hydraulic fracturing fluid is withdrawn. So in other words, they're going to inject that stuff directly into the ground and fracture the rock. So, step 3. Pressurized hydraulic fracturing is injected, that fluid is injected into the well, creates cracks in the geological formation, allows fossil fuel, shale oil, natural gas, whatever it is, to escape. So you're injecting it here, and that stuff escapes and is collected at the surface. And then it's held under high pressure. After that pressure is released, there's this thing called flowback. The fluid that had been injected into the well, as well as the fossil fuel product and all that sort of stuff, it goes back up the well along with that fossil fuel. And then that flowback, all that water you inject in, has to be stored. And it's not just water, it's all that propane stuff too. There's a lot of extra chemicals added to a fracking operation. And fifth easy step, wastewater treatment and disposal. That's not such an easy step because you have a lot of water. It can be injected underground. In fact, and we'll learn this in a later chapter, back I think it's in Unit 5, that often this is the part of the operation where the hydraulic fluid, the waste, is actually injected back into the ground. This is what causes those earthquakes you may be hearing about in the central part of the United States, particularly in Oklahoma. Can be disposed of in surface waters, but not around here. Can be recycled. I would think that would be the wisest thing, although you have to do some reclamation of it. It's an important source, I'm talking about fracking, important source of fossil fuel independence for the U.S. But at what cost? We'll talk a lot more about that in later lectures. So this is the actual website. That hot link should work if you want to see the details of a hydraulic fracturing or fracking operation. So we do have impacts from excessive groundwater withdrawals. Groundwater overdraft. Overdraft, kind of like your checking account. Removal of groundwater rate faster than it can be replenished. Groundwater overdraft is responsible for several important problems, and here are just two of them. Saltwater intrusion. Saltwater intrusion is the movement of saltwater from marine aquifers, also deep underneath ground. If you go back to that image of the Floridan aquifer system, underneath the Floridan aquifer system, even in the middle of Florida, you go down deep enough, you end up in saltwater and brine. Saltwater can end up contaminating potable water supplies. So this is the hydrogeologic cross section. If you look at this, this is Florida Peninsula right here. You can see that we have the coast indicated on that. This area in here is saltwater, and this of course is the freshwater. Freshwater saltwater interface is right there. That's what that black line is. So moving forward, this is a projection. This is a 50-year estimate. 600 million gallons per day withdrawal from certain wells near the coast for 50 years. What's going to happen? So current, you see the current line there. And once again, the saltwater freshwater interface has moved approximately, well, 2 miles is what this graph shows us. This is miles from the coast. It's moved in quite a bit over 50 years. A little more on that. Same interface. What are we saying there? There are wells here that are actually contributing to that removal, and these areas in here are soon not to be able to be used. Notice this is fairly shallow, 450 feet deep. Now, if you had a deeper well in there, you would be have to replace it, have to move it someplace else, find another source of water. Extended saltwater interface in that highly permeable zone. You can see that if we just withdraw 4 million gallons a day is probably that, I guess that amount that doesn't cause that much of an overdraft. Each of these dots is the location of a production well. 600 million gallons a day is what we were looking at in that graphic. 800 million gallons a day pushes that water even further towards the coast, and 1 billion gallons a day is almost unsupportable because it really pushes pulls that drinking water wells quite a ways back. Notice there are also some drinking water wells here on the outside of that saltwater interface. So that overdraft, removing groundwater rate faster is replaced. So the second one is subsidence. Removal of groundwater can cause soil compaction and sinkholes. is going to affect large areas of land, making them unsuitable for human use. And this is actually an assignment. It's been opened. Strawberries threaten to destroy city. It has a funny title, but it's a very serious result of overdraft, overuse of groundwater, causing the land to collapse around it. So you'll find that, hopefully you'll find that interesting. At least you'll find it to be an assignment. Let's look at the impacts of dams and reservoirs to change gears just a little bit, moving away from groundwater. Dams have many positive benefits: power generation, flood control, water storage, particularly drinking water storage. During the Great Depression, there's an organization called the Tennessee Valley Authority, always shorthanded TVA. There were several other projects. I spoke about the Bureau of Reclamation out west. They actually were starting to reduce flooding, create hydroelectric power, which is a green source of energy if you want to look at it from the fossil fuel use. You don't use any, at least once you get the dam built. And economic development, particularly in the 1930s in poor rural America, coming out of the Great Depression, or well, we're in the middle of the Great Depression. The Dust Bowl, all those things are going on at the same time. So this is a map of the TVA. TVA extends from up here in Virginia. And this is the Clinch River coming down here, and then the in North Carolina also, the Tennessee River, and they come together in a little town I like to call Oak Ridge. I used to live there. They then flow, actually come together in Kingston, but nobody knows where Kingston is. And then they flow down towards Chattanooga, flow down into Alabama, and then back a little bit into Mississippi, and back up through Kentucky, and have a confluence with the Ohio River at just outside of Paducah. It's a pretty long, and the elevation of these dams goes from about 1,500 feet above sea level to about 200 feet above sea level over the course of the whole run of it. And this provides a tremendous amount of hydroelectric power. Dams can have detrimental impacts on fish and wildlife. Flood streams can eliminate fish species that live and reproduce there. They starve the estuaries of much needed sediment and nutrients, which is, we think of wanting to reduce the amount of nutrients and sediment flowing into a system, but estuaries have to have sediment and they have to have nutrients to make them productive. Okay, so it's a little different. They also, dams flood terrestrial habitats, affect large numbers of other species, and this is another second assignment right there. Saving California's salmon population, that's a link to it. It's also, again, open in the course homepage under Content Unit 4. Dams can have downstream impacts on rivers, often changing the environmental conditions severely. Water diversions can affect water quality and also remove water from downstream areas that used to flood. What happens when the downstream country wants its own dam? Well, then you have a conflict. This is an article about a dam between Bangladesh and India that I suggest it's interesting reading. I don't think it's, I don't have to ask a question about it, but it's interesting reading. So this is a Farakka Dam on the Ganges between India and Bangladesh. If you look carefully, this is the Indian side here, and they have a very nice hydroelectric system there. They back Ganges up, providing all kinds of water for their folks. And now Bangladesh, of course, wants that same thing for their population, but there's not enough water now, and they're kind of suing India to try to get some of that water, but I don't know how that's going to work out. Sustainable water supply systems. So water conservation is one of those tools that we need to use for sustainable water supply. Traditional approaches have focused solely on supply, damming rivers and streams to provide that supply, that long-term supply. Pumping water from lakes and aquifers, another way just of looking at the supply. We never run out of water, so we might as well just pump and pump and pump because we can't use it fast enough. That's not true. This sustainable approach is to actually conserve water on the use side. So slow down our actual use of water. Ag and industry are the biggest users. Go back to that picture, that image where the number one use of water in the United States is actually for thermoelectric cooling for industry. Also irrigation for crops and a few other industrial uses. But those are the biggest users. They also have the largest impacts because they're the biggest users. That would make sense. Let's look at the Peace River. Peace River actually flows in the western part of I guess, southwest Florida. It has its origin all the way up in Lake Hancock, flows south of Lakeland, all the way through the Polk County into Hardy County, down to Charlotte Harbor, reaches Charlotte Harbor at about Punta Gorda. So this is Kissimmee Springs, 1894, and there's people swimming there. It's quite a good-looking creek as far as that's concerned. Plenty of water. Same spot. This is a guy standing on the ground in 2001. What has happened to all the water at Kissimmee Springs? Well, in 2001, we're in a drought, but that's not what's really going on here. Certainly it would have drawn the water down some, but something else is going on. So there's a lot of phosphate use. Remember back in that 1980 map, we showed that Polk County is one of the highest users of water, of groundwater throughout all of Florida. It also, if you recall, the groundwater is connected to that surface water. They are related. So, groundwater use, 1 million gallons a day in 1980 was greater than 200 million gallons a day. A lot of water. 2005, this is 4 years after that last picture was taken, the groundwater use had dropped by, what's that, 300%, something like that. It's a third of what it used to be. More than a third, 65.8 million gallons a day. Sounds like a lot of water, but not compared to what it had actually been. Projected use is going to drop even further, down to 59.7 million gallons a day. So the lower Floridan aquifer levels lead to lower stream flows in the Peace River because it is a cumulative effect. This is a 1970s image of phosphate. Phosphate interest, that's a really, really big derrick. And the way they did things in the 70s, they would pump water and discharge it. Once they had used it for the phosphate mining purpose of removing some of that, processing the phosphorus, processing the mine till. Today, well, now, they pump, capture, and then recirculate much of the water that they used to use. So, sustainable water supply system. Water conservation. Those traditional approaches to water problems have focused on supply. Obviously, more sustainable approach to conserve on the supply side. So water projects are often subsidized by the government, but do they provide incentives for conservation? Many programs are out there, reducing the amount of irrigation water, improving efficiency, switching to crops that require irrigation on several strategies. They excuse me, low flow toilets, believe it or not, are one of those programs that's used to actually reduce the use of water. We also have a program, you can barely see that, it says Lake Placid Reuse, treating water to a higher standard so it can be used for landscape irrigation. The town of Lake Placid installed reuse lines in its wastewater treatment system. We'll talk more about this in the next lecture, but this is that nice, maybe you have seen this, pink pipe. Pink is basically it's treated wastewater that's being used for, or can be used for, irrigation. Estimated cost for the town of Lake Placid is $1.5 million. And eventually they're going to have users. Right now they don't. They're waiting for residential and commercial development to fill in so they can actually have users of this facility. So we've seen this slide 3 times before. More sustainable approach to conserve on the use side. Quite often, water now is viewed as money. It does cost money to pump water, and the less you have to pump, the less it costs you to actually use. So if you can find a way of irrigating with less water and getting the same crop, well, that's a positive thing. Flooding is one of those ongoing problems. Despite widespread water shortages, flooding is serious in many parts of the world. Very serious problem. Human activities, land use patterns combined with, sometimes we get heavy precipitation, other natural factors to produce floods. Some of those factors are not so natural, but the heavy precipitation, the natural factors such as tropical storms or tropical depressions even, can be enough in the tropics, particularly the Caribbean, to dump lots and lots of precipitation. So, rural versus urban watersheds in terms of the percent pavement, that's another word for imperviousness. Let's look at what that sees. As you increase the percent pavement, you increase how fast that water is going to run off. So this is discharge in terms of the rate, the cubic feet per second, which is also speed. So this is after urbanization. It's much, much faster. Before urbanization, basically there was no pavement, so the water would simply seep into the ground, and there was a lot less impact for flooding to surrounding parcels of land. More contamination comes from urbanization. You have more pavement, more of those sorts of things, and a lot more stuff is being moved quickly from the land surface, the paved surface, the pavement, into our receiving water bodies. When you put in swales, that's all that might be, controlled outflow from detention basins, you greatly reduce, you take the top off of that and you hold on to that water so it dissipates, it flows out more slowly, more like a natural system. So more flooding problems and solutions. Controlling flooding, structural flood control devices and watershed management, two different ways, approaches to controlling this flooding. We often like to move that water faster. Streambed channelization, environmentally destructive thing to do, but it's one of those things that traditionally has been done, certainly throughout history and even our recent history in the last 40 years, although it's not been done very recently because a lot of it has been stopped. Flood walls. Flood walls are very, it's a solid wall like a wall along a lake or a river. It basically eliminates wetland habitat, prevents normal flooding and enrichment of the floodplain ecosystem, and those floodwaters have to go somewhere. If you restrain it with a flood wall, basically further downstream, flooding is worse. Okay. Looked at water shortages. Where is our water used and where does it come from? Remember these three letters, FAS. Floridan Aquifer system is where our water comes from, drinking water in particular. Drought and water shortages. The impacts of the water supply system. Impacts of excessive groundwater withdrawals, both that's the sinkhole formation and the saltwater intrusion. Dams and reservoirs. There are a lot of different things, problems that are caused. Certainly there's some loose solutions from dams and reservoirs, but there's some problems caused by dams and reservoirs. And we looked at creating a sustainable water supply system. Flooding. Problems and solutions. Despite widespread water shortages, flooding is still a problem in many parts of the world. So maybe we haven't solved as many problems as we think we have. Causes of flooding. And how do you control flooding? Sometimes you have to restore wetlands and let them flood rather than simply walling them off. Here are some of the references. Also see the annotations with images noted in the previous slides.